Okay, so I just want to say something about the meaning of this pullback lemma. And basically, it's of use if we have, say, J, and we want to pull it back over G after F. Because what this pullback lemma is basically saying, I'll just restate the assumptions. The assumption is that the right square is a pullback, and the whole diagram commutes, and we're saying that the left square is a pullback if and only if the outer rectangle is a pullback. Now the use is that when we have this J and we want to pull it back along G after F, we can do it in two stages. So if we pull back J along G, then we get these arrows M and I coming out of E. So let's assume we've done that, and obviously there can be different choices of pullback, but they're sort of unique up to isomorphism, so we just pick one. And then what this pullback lemma is saying is that if we then take that I and we pull that back along F, so then we'd be working out the pullback for this left square, we'll get some D, and that D can also be considered to be a pullback of J along G after F. Okay, so I mean, if we just did it randomly, if we just randomly picked a pullback of J along G after F, and got some D over here, and then alternatively, we did it in two steps. So we took our pullback I of J along G, and then we did a pullback of I along F. We may get different results, but they're going to be isomorphic, okay? Because it is possible because what we can always do is we know that if we do pull, we know that they'll be isomorphic. So we know either way we do it, we'll get a pullback of the other way. So if we do it in two steps, if we pull back J along G and then we pull back I along F, we'll get a pullback that could be considered to be the pullback of J along G after F. Or, we can always do it just in one step. We could just pull back J along G after F in one step, and then we'd get something that could be considered to be, it's isomorphic to and could be obtained from pulling back I along F. So that's the basic meaning of the pullback lemma. It basically says that if you pull back a vertical arrow along one horizontal arrow, and then you pull it back again over another horizontal arrow, that's equivalent to just pulling it back over both of those arrows at the same time. So yeah, that's it.